Okay, in this video, what we're going to do is look at functions, and we're going to discover that every family of functions has a parent function. And the idea of a parent function is that it's the simplest function of a family of function, and it preserves the definition or the shape for the entire family. So let's just start out with a quick definition there, some quick ideas about the parent function. And I'd like for you to write this down. A parent function is the most basic function. As I mentioned before, it's the most simplest function. So in other words, there's not going to be a whole lot of detail to it. There's just going to be mainly variables with different exponents, yes, but yeah, you're not going to see much. It's just going to be very basic. Many functions can be pretty decorated, but not the parent function. The parent function will always pass through the origin. Again, I would like for you to write this down. Now that doesn't mean that just because it passes through the origin that it's the parent, but in like manner, the parent function will have to go through the origin, so just be careful about that. So, and again, as I mentioned, every function family has a parent function. So what we're going to do is we're going to take a look at 5 different families. And we're going to start out with this foldable. As you see, you need to adhere it into your notes, and we're going to complete each section. Alright, so we're going to start with the line family. And as you know, a line, obviously the shape of a line is pretty easy. But what makes the parent, this is the parent function, what makes it distinct is it's the simplest function. The degree of this function is 1 because the exponent on that x is 1. And so it's called a first degree equation. And you'll notice that I created a table of values. These values were chosen because they will fit on this patch of graph paper. You'll notice that the left-hand side goes to -5 and the right-hand side goes to 5. So I'm going to choose points here that will fit on that line. So now that we know that y, or f of x, is equal to x, then all I have to do is fill out this table. And what I have is a set of ordered pairs, and it goes through the origin, as you can see, and as I plot those points, you see that it develops into a straight line. Okay, so we talked earlier in other lessons about domain and range. Basically, in this case, we don't have any restrictions on x. We can choose anything for x. We can choose fractions, decimals, high numbers, low numbers. There's absolutely no restrictions. And in like manner, since y is equal to x, there's not going to be any restrictions on the y value either. So what we say for the domain in this situation is all real numbers. In other words, choose anything you like. And same for the range. All right. Let's look at the next family. The next family is our quadratic family, and the quadratic family is a little bit different. You'll notice the parent function here. We've added a 2 for the exponent, makes this a second degree equation, which means that the whole shape of the family is going to be determined by this parent function. So as we look at our table of values, once again, we're going to see that they were chosen in the same way that the other ones were. Keep in mind, whenever you square a negative, you're always going to get a positive. So let's fill out this table. Go ahead and do that in your notes. And again, it goes through the origin. Plot your points. You're not going to be able to plot 3, 9, and -3, 9. So just make sure that you don't go over to the 3 because it goes all the way up to the 9. Alright, so the domain. The domain is a set of x values. Again, there's no restrictions on x. X can be anything. So that will be all real numbers. However, the range can't be anything. Actually, it can't be negatives. So we're going to have some restrictions on this range. We would say in this case that the range is going to be y is greater than or equal to 0. All right, let's take a look at our, this is interval notation, as you know, and so if you want to put it that way, you can. All right, next family is the cubic family. And again, the parent function has a 3 as an exponent. So this parent determines basically the shape of the rest of the family that is a third degree equation. Again, I chose the same values, but you're going to see that we're going to run into a few problems. We'll talk about that here in a second. When I cube negative 3, that's negative 3 times negative 3 times negative 3, I get negative 27. And you can see that we're not going to be able to plot that point or that one. We will be able to plot that one, negative 1 times negative 1 times negative 1. And you'll notice that these replicate each other. They're just opposites. So when I plot these points, you'll notice that it does go through the origin. And those are the only 3 that I can put on this patch. But I need to make sure that at 2, it's going to go up to 8. So we're going to draw it just like that. You know, it looks a little bit like an S curve. The domain, again, there's no restrictions on what I choose for x. So I'm going to say, once again, it's all real numbers. And in like manner, there's no restrictions on the y value, or f of x. There's nothing that it can't be. You see its negatives. You're going to see that it goes all the way up to high numbers, low numbers, and everything in between. So we would say that's all real numbers as well. All right. Next family is the absolute value family. And notice the parent function. It's very basic. Includes absolute value signs. When we plug in these points, keep in mind that the absolute value represents distance from 0, and distance can't be negative. So the absolute value of negative 3 is 3. So once again, what we're finding out is that our y values cannot be negative. So that's going to affect the range. All right, so when I plot these points, you'll notice it goes through the origin. And notice that the right-hand branch kind of looks like a line. Well, it is a line. And notice that if I removed the absolute value symbols, I would have the parent function for a line. So the other branch, seeing that it can't be negative, this is where it differentiates between a line and absolute value, is that it turns around right here, and we plot all our positive y values there. Notice that it takes on the shape of a V. So for absolute value, V, that's a good little mnemonic device for you to remember. And the domain, again, domain can be anything. There's no restrictions on what I can choose for x. However, the range is restricted. You'll notice that we'll never get negatives. And so to denote that, we say y is greater than or equal to 0. All right, our next family is the square root family. There's something that we need to talk about with square roots. Whenever we take the square root of a number, we have to have 2 equal copies, because it's actually the opposite of squaring is taking the square root, or the inverse functions. So keep in mind that if I put a negative underneath there, I am going to run into a problem because I don't get 2 equal numbers. So there's no 2 numbers that I can take, 2 equal numbers that I can take to get negative 9. And so we'll study this a little bit later in this course, but for right now we're just going to say we don't have an answer. And notice that I was very strategic about my x values. I chose all perfect squares. And again, we can't use negatives underneath the radical, so starting at 0, though, we can. So the square root of 0 is 0, the square root of 1 is 1, the square root of 4 is 2, and 3. Notice that it goes through the origin, and we have a couple more points, and we can't really do 9, 3, but we can do a good little sketch of it. So the domain, remember, there wasn't really any problems until we got into the negative zone, so we have to say that the restricted areas, these would be our restrictions, can't use those. So x is going to be greater than or equal to 0, and you'll notice that my y values are also going to be greater than or equal to 0. And this is interval notation is included here. So this concludes the family functions that I would like for you to take notes on, and we'll discuss more in class if you should have any questions. All right, we'll see you then.